This lesson is a review of special right triangles. Alright, when we talk about special right triangles, we are talking about your 45, 45, 90 triangle and your 30, 60, 90 triangle. And basically right here in a nutshell, these are the special relationships that we are going to be remembering. In a 45, 45, 90 triangle, it's always going to be an isosceles triangle. And you can tell because if you look at it the right way, these are base angles that are equal. So of course these two sides will be equal. And then the hypotenuse is going to be that side length times radical 2. Alright, for example, if this is a 45, 45, 90 degree triangle, notice it is isosceles. Let's say if this leg was 7, then the other leg would have to also be 7, and the hypotenuse would be 7 radical 2. On the other hand, you have your 30, 60, 90 triangle. Because we have these two different sized angles, acute angles, we have two different size legs. So across from the small angle, the 30 degree angle, we have the short leg, which we will call X. And across from the larger angle, we have the longer leg. Alright, whatever the short leg is, the longer leg will be that times radical 3, and whatever the short leg is, the hypotenuse will be double that. So I'm hoping you can visualize that it's all about the short leg. Once you know that, double it, you have the hypotenuse, multiply it by radical 3, and you've got the long leg. For example, if you have a 30, 60, 90 triangle, you know the hypotenuse is going to be across from the 90 degree angle, so this is the hypotenuse. Look for the short leg. The short leg is going to be always across from the 30 degree angle. Now if we know the short leg, we have it made. For example, if this short leg was 7, then if you want to know the hypotenuse, you just double it. So the hypotenuse will be 14. Okay? It's all about the short leg. You double it, you get the hypotenuse. Now if you take that short leg and multiply it by radical 3, that's going to give you the long leg. So this will be 7 radical 3. So if you have the short leg, you can get everything else. Now look at problem number 1. We are not given the legs. We are told that the length of this leg is x. So whatever that is, we know that the other leg is also going to be x. But we also know that then the hypotenuse will be x radical 2. Well, comparing these to each other, guess what? X must equal 4. So it only makes sense. So if x is 4, then of course that means both sides will be 4. And of course we will have 4, 4, and then the hypotenuse would be 4 radical 2, which it is. So it makes sense that the leg must be the 4. Now look at problem number 2. We're being asked for the hypotenuse. Okay, we're given a leg. So looking at it this way, these are the two legs. If this leg is 3, the other leg must be 3, and then the hypotenuse must be 3 radical 2. Okay, we're just following the pattern. Alright, it's leg, leg, and then leg radical 2. Okay, so we have 3, 3, and then 3 radical 2 for the hypotenuse. Alright, problem number 2. Again, you can probably immediately see that these must be 8 because the legs will be 8, 8, and then 8 radical 2. So x equals 8 in this case. Alright, kind of a no-brainer. They'll get trickier soon, don't worry. But not yet. So if the hypotenuse, well, first of all, this one we don't have any degrees. So how do we even know that this is a special right triangle? Well, you see that it is isosceles, alright, because the base angles are equal and these legs are marked the same. Is that what was going on here? No, this time they actually gave us the degrees. But they didn't have to. If we have a right triangle, The only way it's going to be isosceles is if these are 45 degrees. All right, they have to be the same. We have 90 degrees. If you take 180, the total, and subtract the 90, that leaves 90 to be shared equally between these two angles. That's 45 and 45. Okay, so we know it'll be the special right triangle, and then we're back to what we were dealing with before. If the hypotenuse is 7 radical 2, that would only happen if the legs were both 7. 7, 7, 7 radical 2. So x must equal 7. Okay, what about number 5? Alright, it's not getting any trickier yet. Again, you see that these angles are equal. They have to be 45 degrees in that case. The only way they can be the same. And using the properties of a 45, 45, 90 triangle. Leg, leg, and then this should be leg radical 2. Alright, so x will equal 5 radical 2. Okay, number 6, still super easy. Again, base angles are equal. They have to be 45 degrees. Alright, that means following the pattern, this would be 4, this would be 4, and then this would have to be 4 radical 2. It's leg, leg, leg radical 2. Okay. Alright, these are too easy, almost boring because they're so easy. We're hoping for a challenge soon. Alright, will this be it? Will this be the challenge that we crave? Alright, let's understand how a chart works. We have this model. If x is 3, then that means that these are both 3. So we would have 3 and 3. And of course, if that's the case, then the hypotenuse would be 3 radical 2. So if x is 3, then y is 3 radical 2. Okay, on the other hand, for this next slot, we are starting all over again. And we're saying if y is 6 radical 2. So that means here we have 6 radical 2. Then what must x be? Well, if y is 6 radical 2, then x must be 6 and 6. So, because it would be 6, 6, 6 radical 2. Alright, fine and dandy. So, similarly, if x is 7, then y would be 7 radical 2. Alright, if x is 2, then it would be 2 radical 2. Okay? No challenge there. Very, very simple. And we are looking forward to the challenge. Maybe the next one. Alright, the tough problems are our favorite. Well, at least we are switching over to the other special triangle, 30, 60, 90. So remember, the pattern here is once we know the short leg, double it, you have the hypotenuse. Multiply by radical 3, and you have the long leg. Alright, of course, the short leg is always across from the 30 degrees. So, whoa, no. Alright, so I suppose the first order of business is understanding which one of these is the short leg. Because for a 30, 60, 90 triangle, it's really all about the short leg. Hopefully you can see that A here is the short leg. Alright, this is the short leg. Of course, C is the hypotenuse. B, across from the 60 here, is the long leg. Alright, so we've got the short leg, long leg, and hypotenuse. Now, it's all about the short leg. So for the first one here, we're given that A, the short leg, in fact, let me just label this. So this is short, this is the short leg, and then B here is the long leg, and then C is the hypotenuse. Okay, so if we're given the short leg is 4, then we've learned that if you multiply it by radical 3, that'll give you the long leg. So that would make this 4 radical 3. And if you double it, so we multiply by radical 3, if we take it and we double it, we'll get the hypotenuse. So if the short leg is 4, the long leg will be 4 radical 3, and the hypotenuse will be 8. Okay? Both of these are coming from the short leg, if you will. Now, working backwards slightly, we can easily imagine that if we're given the long leg is 5 radical 3, okay, so if this is 5 radical 3, well, that would only come from a short leg that is 5, all right, because you're supposed to be able to take the short leg and multiply it by radical 3. So that's going to make the short leg would have to be 5. But then the hypotenuse, you can get that by doubling the short leg. So the hypotenuse would be 10. So it must be 5 radical 3, and 10. This next one is the only one that's even slightly tricky. In fact, let me come back to it. Let me save it for last. Because this one, if we know that the short leg is 6, alright, we'll see how easy that is. If the short leg is 6, then put a radical 3 on it, and you've got the long leg. Double it, and you've got the hypotenuse. So it would be 6 radical 3, and 12. Just like that. Now this last one is slightly trickier, alright? Finally a challenge, and you know how we love a challenge. Let's take a peek at the black screen for a second. Now we know that the short leg will tell us what the other two sides are. The long leg would be 5 radical 3, because you just multiply by radical 3, and the hypotenuse would be 10, because you just double it. But now prepare to work backwards. Alright? What if I told you that this was, let's say, 16? Shouldn't you be able to tell me what the short leg is right now? Sure, if the short leg, if the hypotenuse is 16, that comes from doubling the short leg. So that would mean that the short leg must be 8. And then once you have the short leg, you would be able to tell me what the long leg is. You take the short leg and put a radical 3 on it. So starting with the hypotenuse, we can work backwards, and by taking half of that, that gives us the short leg, which in turn tells us what the long leg is going to be. Now, what happens if the hypotenuse is something slightly more interesting? For example, say if we have 8 radical 3. Now don't be fooled. This is not the long leg, alright? If I told you that the long leg was 8 radical 3, then you would go, oh, well, the long leg is 8 radical 3 only if the short leg is 8, which would make the hypotenuse 16. But that's not what I said, if you're paying attention. I said the hypotenuse is 8 radical 3. Now, how do we get the hypotenuse from the short leg? We get the hypotenuse by doubling the short leg. So if the hypotenuse is 8 radical 3, what would we have to double to get 8 radical 3? Well, this must be 4 radical 3. Okay, in other words, half of 8 radical 3. And if this is 4 radical 3, now here's the trickiest part of all. This just blows students' minds. Okay, how do I get the long leg? Okay, well, how do I say this without hurting your feelings? Okay, we've learned that if we want the hypotenuse, we start with the short leg and then we double it. Okay, and then that gave us, in this case, 8 radical 3. But we've also learned that if we want the long leg, we start with the short leg, which is 4 radical 3, and then we multiply it by radical 3. So it's just a matter of what is this? Well, hopefully you remember from a long time ago that radical 3 times radical 3 is just 3. I mean, that's true for any radical. You know, radical 5 times radical 5 is just 5. All right? I mean, it makes sense because radical 3 times radical 3 is radical 9. And of course, the square root of 9 is 3. So anyway, radical 3 times radical 3 is 3. And then we still have the 4 that I just bring down. So this winds up being 4 times 3, which turns out to be 12. Okay, so the long leg turns out to be 12. So let's just work backwards and understand. Okay, in fact, let me go ahead and jump back to the actual problem. They gave us that the hypotenuse was 8 radical 3. Okay, so if the hypotenuse is 8 radical 3, now working backwards, we get the hypotenuse by doubling the short leg. So the short leg must have been 4 radical 3, because that's what, if you multiplied by 2, would give you 8 radical 3. So that wasn't too hard. But then understanding what the long leg is going to be. So far we know that if the hypotenuse was 8 radical 3, the short leg is 4 radical 3. Okay? But looking back at the pattern, we should be able to get the long leg by starting with the short leg and then multiplying it by radical 3. It doesn't matter that there's already a radical 3 in it. Okay? When we have 5 as a short leg, the long leg was 5. Okay, we started with 5, and then we put down 5, and we put a radical 3 next to it. 5, 5, radical 3. 6, 6, radical 3. 4, 4, radical 3. So here we have 4 radical 3, and then we have 4 radical 3, radical 3. Whatever you have, you write that down and then multiply it by radical 3. But like we discussed on the other page, 4 radical 3 times radical 3 is really just 4 times 3, which is 12. Okay, some of you are with me. I know I blew some of your minds on that one. Practice makes perfect. You'll catch up with me. Don't worry. So that one is going to be 12. All right, I love that problem. All right, the other ones kind of boring, but the fun problems are the ones that make you think. Don't you find? All right. Anyway, hopefully we'll run into a few more of those to help us reinforce. Find the value of each variable. Okay. They gave us the hypotenuse. All right. So here's a way you can sort of think about it. Well, this one's pretty easy. We know the pattern for 30, 60, 90 triangle is like this. Now, instead of using x's, I'm going to use some other variable. Okay? I'm going to use b's for Burton. So, the short leg would be b, and the hypotenuse would be 2b, because you'd have to double it. And then the long leg would be b radical 3. Okay? But look what we have here. We have 2b is equal to 6, right? So hopefully you can see that one way to look at it is you could just divide this by 2, and that's going to tell you that b is 3. All right? I mean, you could have gotten that from your common sense. So that means this b, this side over here, also known as x, is going to be 3. And then once you know the short leg is 3, then of course the long leg will be the short leg times radical 3. Okay, so did we have to use the equation? No. you could just use your common sense and say, oh, the hypotenuse is 6, the short leg will be half that, and then once you have that, just multiply by radical 3 for the long leg. Alright, trying to give you more than one way to solve these. So looking at number 10, it's all about the short leg. Anytime they give us the short leg, we are home free. So look, this time they were kind enough to give us the short legs across from the 30. So we know if we want the hypotenuse, you double it. So we take this and we double it. That's going to give us 4 radical 3. So that's our y value. Okay, now if we, again, this is like the very interesting problem we did back on problem number 8. The long leg is the short leg times radical 3. So this long leg is going to be the short leg, all right, 2 radical 3, times another radical 3. Now, how do we handle this? Do you remember? Well, hopefully you have learned now that if you multiply radical 3 times radical 3, you're just going to get 3. And then I could just bring down this 2. So I've got 2 times 3. So that's going to be 6. Okay, so x is going to be 6. And y is 4 radical 3. Alright, these are some of the most interesting problems because you really have to think about it a little bit. Look at number 11. Let's see, what did they give us? They did not give us the short leg, did they? They gave us the long leg, okay? So, and it's not even something that has a radical 3 on it. So here's how I like to approach this type of problem. Again, I like to do this. I'm going to use these symbols, alright? But instead of x's, I'm going to use b's. So I'm going to go b, 2b, b radical 3. Alright, same diff. I'm doing that to avoid the fact that they use x already in the problem. So I'm going to use b's instead. Okay, so the short leg, it's all about the short leg, remember? So that would make this b. And then the hypotenuse would be 2b. And then the long leg would be b radical 3. Alright, so I've got b, 2b, and b radical 3. Now, focus your eyeballs on the one where we have an actual number. Alright, b radical 3 equals 9. We can solve this and find out what b is. And once we have b, we can find the other two things. So how would I solve this, you say? Well, we would just divide both sides by radical 3. Okay, to cancel those out. So that is going to tell me what b is. So 9 divided by radical 3. Okay, so if we do 9 divided by radical 3, that gives us 3 radical 3. Okay, so b is 3 radical 3. Now we need to translate that into x and y. Well, this part is super easy because b is y. Okay, so that means that y is 3 radical 3. Okay, so that y must be 3 radical 3, alright, because that was the same as b. Let me see if I can do that a little bit better. And now for the hypotenuse, of course, we'll take this and double it. So we'll take this b and we will double it. So that'll be 2 times 3 radical 3, which of course is 6 radical 3. Okay, so x is 6 radical 3 and y is 3 radical 3. Now before we move on, go back to this. What if you had to do 9 divided by radical 3 but you were not allowed to use a calculator? What then? Well, let me just show you that real quick. 9 divided by radical 3. Alright, we do something that's called rationalizing the denominator. So if I have 9 divided by radical 3, if I want to rewrite this without a radical in the denominator, I can do that by multiplying by radical 3 in the numerator and the denominator. And it's okay to do this because anything over itself is just 1, and multiplying by 1 doesn't change the value of the expression. But if I do this, then what I get is radical 3 times radical 3 is just 3. And then up here I have 9 times radical 3. Well, that's just 9 radical 3. However, this part right here I can simplify. 3 divides into 9 3 times. So that's why this is going to become 3 radical 3. Okay, the 9 divided by 3 is the 3, and then the radical 3 just comes down. So that's how you would find it if you were not allowed to use your TI-30XS multi-view. Alright, this video is getting long, so I'm hoping, let's see, how many more of these problems are there? Alright, I might have to stop this video pretty soon. Or, you know what, maybe I'll just accelerate. So, here we go. I'm going to do the rest sort of fast because I think we're getting the idea, and I don't have to go this slow anymore. Okay, you see that it's isosceles. So, the only way it's going to be an isosceles right triangle is if both of these are 45 degrees. So kabam, that's y. And then the pattern of the 45, 45, 90 triangle is leg, leg, leg radical 2. Okay, so that means leg is 7. So 7, 7, and then 7 radical 2. So x is 7 radical 2 and y is 45. Okay, number 13. Okay, look, they're telling us that y is the short leg. Alright, we're calling that y. So that means, well, first of all, 30, 60, 90. So let's just get that out of the way. X is 60. Now, y is the short leg. The hypotenuse is 10. That means this must be 5. Alright, because the hypotenuse, you can always get it by doubling the short leg. So if the hypotenuse is 10, y must have been 5. Number 14. Okay, the short leg, we have this expression 2x. Okay, you know what, I might have to do that thing that I do. Okay, I'm going to use the pattern of the 30, 60, 90 triangle, alright? But instead of x's, I'm going to do b's. So this will be b, 2b, and then b radical 3. Okay, so for now, I will call this b, and that's going to make this 2b, and that's going to make this b radical 3. Actually, I feel silly now because looking at the b radical 3 equals 6 radical 3, it's easy to see that the short leg must be 6. Okay, in other words, you see the b and the 6, you know, b is clearly 6. Alright, so if this is 6, then that means 2x is equal to 6. Well, guys, if 2x is equal to 6, how do I find x? Yeah, just divide by 2. Alright, really simple. So that's going to give us that x is equal to 3. Okay, so fine, x is equal to 3, but in the meantime, the short leg here is 6. B is 6. Now the hypotenuse, we should be able to get the hypotenuse by taking the short leg and doubling it, alright, 2 times b. So of course, 2 times 6 is 12. So that's why y is going to equal 12. So y is 12, and meanwhile x is 3. Okay, and overall it makes sense. Hypotenuse is 12, half of that is short leg is 6, and then the long leg is 6 radical 3. So it does make sense. Okay, we have to get through this. The video is getting way too long. Another 30, 60, 90 triangle. So that makes this would have to be 30. All right, x is 30, and I'm not sure what kind of symbol that is, but that's 30. The hypotenuse is 10. That means the short leg must be 5. Okay, so y is 5 and x is 30. Looking at number 16. We have radical 2. Normally we have things like this, like 5, 5, and then 5 radical 2. But this time we just have radical 2. All right, what do I do with that information? Well, one way to think about it is think of this as being 1 radical 2. All right, so then you can maybe see that this must be 1 and this must be 1. So it's like 1, 1, 1 radical 2. All right, so y must be 1. Meanwhile, these angles, isosceles, base angles, the angles have to be 45 degrees, right? So look at the little equation I have. 5x must equal 45 degrees. So to find x, just divide by 5. So that's going to give us x is equal to 9. Alright, so x is equal to 9 and y is equal to 1. Okay, 2 radical 3 is the short leg. Well, let's go ahead and deal with the x. Alright, you know, in the context of 45, 45, 90 triangles and 30, 60, 90 triangles, it would be a good hypothesis to think, well, could this be 30 and could this be 60? And but then when you think about it, that's the only angle that it could be, because we have x and we have 2x. So this angle has to be double this one, and yet they all have to add up to 180 degrees. So the only way for that to happen, for both of those things to be true, is if we in fact do have a 30 degree angle, a 60 degree angle, and a 90 degree angle. So anyway, x is 30, alright, so we're halfway there. That makes this the short leg. So remember, if I have the short leg, I can double it to get the hypotenuse. That would be 4 radical 3, which we didn't need, but whatever. But then if we take it and we multiply it by radical 3, that will give us the long leg. So again, I'm going to start with the short leg, 2 radical 3, and then I'm going to multiply that by an additional radical 3. Alright, I'm doing the short leg times radical 3, 2 radical 3 times radical 3. And by now we have learned that radical 3 times radical 3 is 3. So that leaves us with 2 times 3, which is 6. So that's why y is equal to 6. So y is 6 and x is 30. Okay, what else you got? Now, the side lengths of a triangle are given. Determine whether it's a 45, 45, 90, a 30, 60, 90 triangle, or neither. Okay, well, looking at the patterns, let's take a quick glance. If it's going to be a 45, 45, 90 triangle, it has to be isosceles. So I should have 2 sides the same and then with a radical 2. So that should be easy to spot. Okay, on the other hand, if it's 30, 60, 90, none of them should be the same, but there should be a small one, and then if you double it, that should be another one. And if you take the small one and you multiply by radical 3, then that should be the third one. Okay, so look for the 45, 45, 90 triangle to involve radical 2, and the 30, 60, 90 triangle should involve radical 3. Isosceles, all three different. Okay, what do we have? Is this isosceles? No. But maybe it's a 30, 60, 90. Start with a short leg. Alright, imagine that this is the short leg. If you double it, we should get the hypotenuse. Okay, this could be the hypotenuse. If you take the short leg and you multiply it by radical 3, that should give you the long leg, and which is what we have. So that means this must be a 30, 60, 90 triangle. Okay, short leg, double it, hypotenuse, multiply by radical 3, get the long leg. This one is going to be a 45, 45, 90 triangle. Okay, how do you know? Because it's isosceles, alright, leg, leg, and then leg, radical 2. Leg, 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 radical 2. That's the pattern of the 45, 45, 90 triangle. This one is going to be neither. It's not isosceles, so I know it's not going to be 45, 45, 90. Now, let's imagine, what if it's a 30, 60, 90 triangle? If that were the case, then that would make this the short leg. Double it, we should get a hypotenuse. So, kabam. We do have double it. But then, if I take the short leg and I multiply by radical 3, that should give me the other side. In other words, instead of 8, if this was going to be 30, 60, 90, it should have been 6 radical 3 instead. Since it wasn't, this is going to be neither. Alright, I think, I thought we were done. Man, this is a long video. I apologize. This is going to be another 45, 45, 90 triangle. It's isosceles, and then we have leg, 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 radical 2. That's the pattern. Okay, over here, it's looking like 30, 60, 90 triangle. Okay, always start with the short leg on these. Short leg, double it. There's your hypotenuse. Take the short leg, put a radical 3 on it, and you've got your long leg. So it fits the pattern. Okay, 3, 4, 5, that's neither. Okay, it's not even close. Not even close. It's not isosceles, so it's not 45, 45, 90. If it was trying to be 30, 60, 90, this would be the short leg. Double it, and you should have the hypotenuse. But what? Nothing. Alright, there's no 6, so it breaks down immediately. Okay, so this should be like a 6, and this should be 3 radical 3. Okay, because you double it, you get your hypotenuse, multiply by radical 3. So that was just completely wrong. So that's definitely neither. Now, that was the last problem. Longest homework of the millennium. Okay, guys, I hope it was helpful. I hope you're still awake. Wake up! Go to bed. Or get to class, whatever.